Hello everyone, welcome to my first lecture after spring break. I hope all of you are healthy and safe in your homes. So I think all of you have got my email regarding how I'm going to conduct my classes for the rest of the semester. So your next test will be test 3 and it is scheduled on 3rd April. So test 3 will mainly cover note 8 from Canvas, and in note 8 you basically have these 7 topics. You have Riemann sum, you have indefinite integrals, you have evaluation of definite integrals, you have average value of a function, you have properties of definite integral, you have geometric interpretation of definite integrals, and you have the fundamental theorem of calculus. So these 8 topics will figure out in your test 3. Now the remaining topics which are there in test 3 are excluded from the syllabus. Okay, so you have to only study these 7 topics. So before the spring break, I think we have done Riemann sum, we have practiced some problems on Riemann sum, and I assigned you homework on Riemann sum, and I think all of you are doing the homework. So today we'll start with indefinite integral. So the first lecture will be based on indefinite integrals, evaluation of definite integrals, and average value of the function. So these 3 topics will be my lecture video 1, and so these 3 topics will be my lecture video 1, and these 3 topics, that is indefinite integral, evaluation of definite integral, and average value of a function, this will figure out in your homework 8. Right, so indefinite integrals, evaluation of definite integrals, and average value of the function, these 3 topics will come under homework 8, and this will comprise my first video, that is this video. The remaining 3 topics, properties of definite integral, geometric interpretation of definite integral, and fundamental theorem of calculus, these 3 topics will be my lecture video 2. And this will mainly be homework 9. So after lecture video 1 and lecture video 2, before the spring break, before the exam, I'll upload one more video which would tell you how the tests should be conducted, how test 3 would be conducted. So let's not waste any time, and let's start with indefinite integrals. So so what is an indefinite integral? So first of all, to understand this, let's understand what an antiderivative is. You take a function fx, let fx be a given function. So let us denote it by capital Fx. So let capital Fx be a given function. Let Fx equal to f prime x is equal to d dx of fx be its derivative. So you take a given function and you compute out its derivative. So the derivative is denoted by small fx. So if in such a case, this function will be called the antiderivative of this function. In such a case, the original function capital Fx is called the antiderivative of the function fx, that is the derivative. Okay, so this is very simple. You take a function and you compute out its derivative. So the original function will be called the antiderivative, that is the reverse of derivative of the function fx. Now suppose somebody gives you the derivative, that is somebody gives you fx, and you are asked, tell me the original function fx whose derivative is fx. That is, given a function fx, you want to find out its antiderivative. So this is the problem. The process of finding antiderivative is called indefinite integral. Okay, the process of finding derivative is called indefinite integral. Right? So if you are given this function, that is you are given fx, how you want to trace back and find out the original function, this process is called indefinite integral. So this should be antiderivative. The process of finding antiderivative is called indefinite integral, and we use the symbol integral fx dx for the antiderivative of. So if you are given a function fx, we use this symbol integral fx dx. So we read this as integral, we push this symbol, we use a stretched s, the function dx. This whole symbol, what does this whole symbol represents? This whole symbol represents the antiderivative of this function fx. Okay, now let's try to understand this with a simple example. You take a function fx equals to say x square, right? So you compute out its derivative. So its derivative is small fx, and this is d dx of capital Fx. This is d dx of x square, which gives you 2y6. So you compute out the derivative of the function capital Fx. In such a case, this original function x square, so fx equals to x square, will be called the antiderivative of fx equals to 2x, and we will write integral 2x dx equals to x square, right? So if fx equals to x square is our given function, you compute out its derivative and you get 2x. If you integrate 2x, you get back x square. So in this way you see that differentiation is just the reverse process of integration. So integration and differentiation, these are reverse processes of each other. So we took the function x square, you compute out its derivative. So ddx of x square, that is the derivative of x square, gives 2x. So if you take the derivative of this function, you get 2x. And again, if you integrate this function 2x, you get back x square. So this implies that derivative and integration, these are reverse process of each other. If you take the derivative of x square, you get 2x. If you integrate 2x, you get x square. So the whole first part will just be finding this value of this integral for a given function fx. Okay, so this shows that indefinite integral and differentiation are reverse processes of each other. Now what we will study is, if you are given a function fx, how to find out the value of integral fx dx. So if for any given function fx, how can we find out this, right? That is, how to find out the antiderivative of this function. So there are some rules that we will study now, and then we'll do some problems. So first of all, rules. Rules for finding indefinite integrals. So just like derivative, there are some very beautiful rules and formulas which you need to use to find out the value of integrals. Okay, so the first formula is this: integral x to the power n dx, it is equal to x n plus 1 by n plus 1, provided n plus 1 not equal to 0, that is n is not equal to minus 1, right? So for any n, any natural number n, the value of integral of xn dx, you can use this formula. It is x n plus 1, that is we add 1 to the power and subtract and divide it by n plus 1. Now let's prove why does this formula hold true, right? So observe that we have just studied that differentiation and integration are reverse processes of each other. So let's differentiate this function and see what happens. So d dx of x to the power n plus 1 by n plus 1. So you can take constants out. So I am taking constant out. I am left with d dx of x to the power n plus 1. Now by power rule, to find out ddx of x to the power n plus 1, I am going to bring this n plus 1 to the front and subtract 1 from the power. So it will be n plus 1 minus 1. And then n plus 1 and n plus 1 cancels, and you see you get x to the power n. So the derivative of this gives you xn, and hence since difference, so the difference, when you differentiate this, you get xn. And since we have just studied that differentiation and integration are reverse processes of each other, so if you now integrate this function, you will get back that function. So this is how the first formula came. integration xn dx equals to xn plus 1 by n plus 1, provided n not equals to minus 1. So this, because why n plus 1 not equals to 0 or n not equals to minus 1? Because if n plus 1 becomes 0, you see that the denominator becomes 0, and division by 0 is not defined in mathematics. So this is the formula, and this is how it came. Now there are other formulas also. The next formula is integration sin x dx equal to minus cosine x. You can also check this formula. If you differentiate this, if you differentiate minus cosine x, you will see that you will get sin x. Therefore, since differentiation and integration are reverse processes of each other, so integral of sin x dx will be minus cosine x. You should quote these formulas to memory. The third formula is integral of cosine x dx is sin x. So integral of cosine x dx is sin x. The fourth formula is integral of sec square x dx equals to 10x. The fifth formula is integral of cosec square x dx equals to minus cot x. The next formula is integral of sec x tan x dx equals to sec x. The last formula is integral cosec x cot x dx equal to minus cosec x. Also, there are two additional formulas which you may also want to know. So integral of 1 by x dx is ln absolute value of x plus c, and integral of e to the power x dx equal to e to the power x. So these are the 9 formulas which you need to know. The first is integral xn dx is xn plus 1 by n plus 1. The second formula is integral sin x dx is minus cosine x. The third formula is integral cosine x dx is sin x. The next formula is integral sec square x dx equals to tan x. The next formula is integral cosec square x dx is minus cot x. The next formula is integral sec x tan x dx is sec x. The next formula is integral cosec x cot x dx is minus cosec x. The next formula is integral 1 by x dx is ln absolute value of x, and integral e to the power x dx is equals to e to the power x. So all these formulas are also there in the note 8. So these formulas will be used to do all the problems on indefinite integrals. So now, these basically these 9 formulas you need to understand. So now let's study some algebra of integral before we go to the problems. So algebra of integrals. So the rule 1 is integral of fx plus gx dx is integral of fx dx plus integral of gx dx. So if you have two functions and you have the sum of two functions, and if you have an integral, you can split the integral among its two terms. So integral of fx plus gx dx is equal to just the integral of the first part plus the integral of the second part. So integral of the sum of two functions is the sum of the integrals. Basically this means that if you have two functions, you can just separate the integral. Rule 2 is, if you have difference, so integral of fx minus gx dx, this is equal to integral of fx dx minus integral of gx dx. So just like the sum, if you have difference, you can also split the integral into two parts. Rule 3 is, just like limit and differentiation, if you have a constant inside the integral, if you have some c, some any constant times fx, if you have a constant times fx, you can always take the constant out and write down c times integral of x dx. So if you have a constant means any number, 1, 2, 3, 4, any finite thing, you can always move that constant out of the integral. So these are the three rules. So now we are in a position to do the exercise problems. The first problem, but before we do the exercise problem, let me tell you something very important. So suppose you differentiate this function ddx of x cubed. What you get? You get 3x squared. So just we have studied the differentiation and integration. These are reverse processes of each other. So from this thing we can write integral 3x squared dx equal to x cubed. We can write this, since differentiation and integration are reverse processes. If ddx of x cubed is 3x squared, so integral of 3x squared is x squared. Now what if you differentiate ddx of x cubed plus some constant? C is a constant. What happens when you differentiate this? So this is equal to ddx of x cubed plus ddx of c. Now ddx of x cubed is 3x squared and ddx of a constant is 0. So this is just 3x squared. So you see that if you integrate this 3x squared, you also get x cubed plus c, because differentiation and integration are reverse processes. So if I differentiate x cubed plus c, I get the same answer, 3x squared. So the integral of this function, I get two results, right? In the first case I get x cubed, and in the second case I get x cubed plus c. So in general, you see that is why when we write down the value of integral, we always, after doing the problem, we always add a constant c at the end, right? Because the value of an integral could be this or this plus a constant. That is why whenever we will do some problems on finding indefinite integral, at the end always add a constant c plus c. Okay, so this should be remembered in all problems of indefinite integral. After you compute out do everything, before you write down the result, just add plus c. Now let's start doing the problems. So we are doing the first exercise from second exercise from note 8, which contains problems on indefinite integrals. So problems. The first problem is this: evaluate integral x minus 12 sine x dx. Right? So you want to evaluate this. So how to evaluate this? So first of all, note that if you have a function like this, x minus 12 sine x dx, we have just studied that if we have two terms, we can split the integral into two terms. We can write this as x dx minus integral 12 sine x dx, right? Also, we have just studied that constants can be taken out, so we can write this as x dx minus 12 integral sine x dx. Now, from that table of formulas of indefinite integral, you will see that the formula of xn dx is xn plus 1 by n plus 1. That is, you add 1 to the power and divide by n plus 1. And you'll also see that integral of sine x dx is minus cosine x. So using this formula, you see that this one, you can write this as x, since the power here is 1 plus 1 by 1 plus 1 minus 12 integral of sine x is minus cosine x. So you get x squared by 2 plus 12 cosine x, and as I just stated, just before writing the answer, you will add c. So this is how to do a problem on indefinite integral. So you have two terms, it's very simple. You first split it, you split the integral, two terms. You take the constants out, then you apply this formula. This formula is extremely important. Integral xn dx is xn plus 1 by n plus 1. Using that, you get integral x dx is x1 plus 1 by 1 plus 1. Integral of sine x dx is minus cosine x. You just put them and simplify. And lastly, at the end, put c. Now let's do the second problem. So the second problem is evaluate integral x cubed minus 6x dx. So the same thing, we split the integral. So this is integral x cubed dx minus integral 6x dx. You can take the constants out. So you get integral x cubed dx minus 6 integral x dx. Then you get integral using that formula, but writing down the formula again. Integral xn dx is xn plus 1 by n plus 1. Using this formula, you get it as x3 plus 1 by 3 plus 1 minus 6 x1 plus 1 by 1 plus 1. You get x to the power 4 by 4 minus 6 x square by 2. So this is x to the power 4 by 4 minus 3 x square. Lastly, put a constant c at the end. Now let's take the third problem. So the third problem is integral 2t square plus t square square root of t minus 1 by t square dt. So how do you solve this? So observe that you can write integral 2t square plus t square square root of t minus 1 by t square dt as. So you can write the first term to whenever you have more than one term in the numerator and you have one term in the denominator. So you have three terms. You have 2t square, t squared square root of t and minus 1. So you split the integral as follows. You take the first term 2t square divided by t square dt, put this sign plus. You take the second term, this is t squared square root of t. You divide it by t square. Then you take the third term, which is minus 1. You put minus integral 1 by t square dt. So whenever you have more than one term in the numerator and one term in the denominator, this is what you do. You take the first term divided by denominator dt plus the second term divided by denominator dt minus the third term divided by denominator dt. Now you see that things are getting cancelled. T square cancels out. Here also t square cancels out. So from the first term you just get 2 dt. From the second term you get square root of t dt, and from the third term you get 1 by t square dt. Observe that 2 can be taken out. Square root of t can be written as t power half dt, and 1 by t square, it can be written as t power minus 2 dt. Now here I have nothing, I have just 1, so I can just put t to the power 0 because it's 1. Then again using the formula integral tn dt equal to tn plus 1 by n plus 1, I get 2. This will be t 0 plus 1 by 0 plus 1 plus t half plus 1 by half plus 1 minus t minus 2 plus 1 by minus 2 plus 1 plus c, right? And you will get this as 2t plus t to the power 3 over 2 by 3 over 2 minus t minus 1 by minus 1 plus c. If you further simplify it, you get 2t plus 2/3 t 3 by 2 plus 1 by t plus c. So just to let you know, I have included the solution to all the note problems in the canvas, and also I will also mail you the solution to all the note problems. So even if you miss writing this, you can just have the ready-made solutions. So I will mail you the solutions also. So now you can just try to understand. Now let's try to do the next problem. Question number 4. The next question, question number 4 is integral 4 plus 6u by square root of u du. So you can split this just like earlier as 4 by square root of 2 plus du plus integral 6u by square root of u du. So this gives you, you can take the constants out, you get 1 by square root of u du plus 6 times u by square root of u du. So you can write down this as u to the power minus half du plus 6. You can if you take the difference of the powers, you get 1 minus half du. Since the power is 1 and the power is half, so you get 4 u to the power minus half du plus 6 integral u to the power half du. So you get 4 u to the power minus half plus 1, just using the earlier formula, divided by minus half plus 1 plus 6 u to the power half plus 1 by half plus 1 plus a constant c. So you get 4 u to the power half by half plus 6 u to the power 3 over 2 by 3 over 2 plus c. So you get 8 u to the power half plus 4 u to the power 3 over 2 plus. This is very simple. So in the first step, we take the constants out. We realize that 1 by square root of u is u to the power minus half. Here I have power 1 in the numerator and root over u as in the denominator. So I'll just differentiate the power. So it will be u to the power minus half plus 1 by minus half plus 1, 6 u to the power half plus 1 by half plus 1. Now let's take the next problem, question number 5. The next problem is integral 2x minus 3 times 4x square plus 1 dx. So first, to do this, you need to apply the distributive law. That is, first multiply 2x with 4x square plus 1, then minus 3 times 4x square plus 1, then put dx. Then what you do is, you then multiply 2x and 4x square, 2x times 4x square, then you multiply 2x and 1, then you multiply 3 times 4x square and 3 times 1 dx. So you multiply 2x and 4x square, you multiply 2x and 1 minus 3 times 4x square, 3 times 1. Then you simplify it. You simplify it, you get 8x cubed plus 2x minus 12x square minus 3 dx. So if you can, now just like the earlier one, we'll split it. It will be 8x cubed dx plus integral 2x dx minus integral 12x square dx minus integral 3 dx. So 8 can be taken out, the constants can be taken out. 8 integral x cubed dx, 2 can be taken out, 2 integral x dx minus 12 x square dx minus 3 integral dx. So applying that formula, you get 8 times x 3 plus 1 by 3 plus 1 plus 2 x 1 plus 1 by 1 plus 1 minus 12 x 2 plus 1 by 2 plus 1 minus 3. So it will be x to the power, I have nothing here, so that means x to the power 0. It will be x to the power 0 plus 1 by 0 plus 1. So ultimately plus a constant c. So you simplify, you get 8 x to the power 4 by 4 plus 2 x squared by 2 minus 12 x cubed by 3 minus 3x plus c. Then you can simplify it. So the various steps are as follows. In the first step, I have just tried to apply distributive law to this expression. So multiply 2x with 4x, the whole thing, minus 3 with the whole thing. In the second step, and now I have multiplied this with this, 2x times 4x squared plus 2x times 1 minus 3 times 4x squared plus 3 times 1. So ultimately, if you expand this, you will get 8x cubed plus 2x minus 12x squared minus 3. Then the rest is very simple. You can take the constants out and then apply that integral formula and then finally simplify it. Now let's take the next problem. So the next problem is integral 1 by x square minus 4 by x cubed dx. This is very easy. So observe that you can write this as, first of all you break it, integral 1 by x square minus integral 4 by x cubed dx. Then you write the first one as x to the power minus 2 dx. Take constants out, you get 1 by x cubed dx. You can write 1 by x cubed as x to the power minus 3 dx. Then apply the integral formula. You get minus 2 plus 1 minus 2 plus 1 minus 4 x minus 3 plus 1 by minus 3 plus 1 plus c. So you get x to the power minus 1 by minus 1 minus 4 x minus 2 by minus 2 plus c. So you get minus 1 over x plus 2 over x square plus c. So this is how you, let me just repeat the steps. First you just break it. You can write this as 1 over x square dx minus 4 over x cubed dx. Then 1 over x square can be written as x power minus 2 dx minus 4. 1 over x cubed can be written as x power minus 3 dx. Then you take the constant out and then apply. It will be minus 2 plus 1 by minus 2 plus 1 in accordance with this integral formula. Integral x n dx equal to x n plus 1 by n plus 1. In accordance with that, it will be just minus 2 plus 1 by minus 2 plus 1 minus 3 plus 1 by minus 3 plus 1, then simplify it. I advise you to keep a pen and a paper while listening to this lecture so that you can slow down my lecture and pay attention to each of these problems. Always keep a pen and a paper with you when you are listening to these lectures so that you understand each and everything nicely. Don't watch my video like a movie, then you will not understand anything. So always keep pen, paper, and also I'll give you the solutions to all these problems. Whatever I am doing will also be there. Keep your notes together side by side and then listen to the lectures. Then you will understand everything. So let's take the next problem. Question number 7. Integral 1 plus cube root of x divided by square root of x dx. Same thing, you can split it, you can write down 1 by square root of x plus cube root of x by square root of x dx. Then you can write down this as x to the power minus half, and here you have x to the power 1/3 in the numerator, x to the power half in the denominator. So you get x to the power minus half plus x to the power 1/3 minus half dx. So you get x to the power minus half plus, so you are going to add these two fractions, 1/3 minus half, so it will be 2 minus 3 divided by 6 dx. This is x power minus half plus x power minus 1/6 dx. So this gives you x power minus half plus 1 by minus half plus 1 plus x minus 1/6 plus 1 by minus 1/6 plus 1. To take the integrals of value of this plus, so you get, if you simplify this, you get x power half by half plus x power 1 minus 1/6 would be 5/6. 1 minus 1/6 would be 5/6, so it will be 2x half plus 6/5 x 5/6 plus a constant of integration. So it's extremely easy. So first you can see that you have two terms in the numerator. So you see that you have two terms in the numerator and exactly one term in the denominator. So you split it. So you have 1 by square root of x plus 3 cube root of x by square root of x. Then 1 by square root of x can be written as x power minus half. Cube root of x can be written as x power 1/3. Square root of x can be written as x power half. Now since I have x to the power 1/3 in the top in the numerator and x to the power half in the denominator, so we can just subtract the powers. So here I have x to the power minus half and I have 1/3 minus half, so it will be 2. It will be 2. See, 2 times 1 is 2 minus 3 times 1 is 3 divided by the product of the denominator, which is 6. So x to the power minus half plus x to the power, so if you 2 minus 3 is minus 1, minus 1 by 6 dx. Then at this stage we are just left with application of this formula. Xn dx is xn plus 1 by n plus 1. Using that you find out this and just finally simplify it, and at the last step don't forget to put a c. Okay, now let's take the next problem. Question number 8. The next problem is integral 1 plus 2x whole square dx. Okay, So here you have to use the formula for a plus b whole square. So a plus b whole square, you all know it's a square plus twice ab plus b square. So using this formula, you can write this as integral 1 square plus 2 times 1 times 2x plus 2x whole square dx. So you simplify this, you get 1 plus 4x plus 4x square dx. Then if you further split it, you get integral 1 dx plus integral 4x dx plus integral 4x square dx. Integral of 1 dx, I think by now you all know that integral of dx is just x. 4 can be taken out, you get x dx. 4 can be taken out here also, you get x square dx. Then I finally apply the formula. 4 power is 1, so it will be 1 plus 1 by 1 plus 1 plus 4, and the power is 2, to be 2 plus 1 by 2 plus 1 plus a constant c. So ultimately you get x plus 4 x squared by 2 plus 4 x cubed by 3 plus c. So if you simplify this, you get x plus 2x squared plus 4 by 3 x cubed plus c. So it's extremely easy. So here you, in the first case, you just apply this formula, a plus b whole square. It's a square plus twice ab plus b square. Using that, you break it, you get 1 square plus 2 times 1 times 2x plus 2x square. Then you simplify it, 2 times 2x is 4x, 2x square is 4x square. Then you split the integral, take constants out. Integral of dx is just x, and then finally use this formula. Integral x and dx is x n plus 1 by n plus 1. Using this, so here I think it's not visible, I will write it here. Integral x n dx is x n plus 1 by n plus 1, and then using this thing, if you put it here, you will get these results. Now let's take the next problem. Next problem is integral 3 plus x square root of x dx. So how to do this problem? It's very easy. So you first split it. You can write this as integral 3 dx plus integral x square root of x dx. You just split it. Then you see that 3 can be taken out. You get integral dx. You can add the powers. You have x times square root of x. So you can write this as x to the power 1 plus half dx. Integral dx is just x. This is x to the power 1 plus half is 3 over 2 dx. So this is 3x plus x to the power 3 over 2 plus 1 by 3 over 2 plus 1 plus a constant c. So you get 3x plus, if you add 3 over 2 plus 1, you get 5 over 2. If you add 3 over 2 plus 1, you get 5 over 2 plus c. So you get 3x plus 2 over 5x 5 over 2 plus c. So it's extremely easy, very easy. So first you break it. So integral 3 plus x square root of x. Since I have two terms, I can break this as integral of 3 dx plus integral of x square root of x dx. Now 3 can be taken out. You can add the powers. Here I have 1 square root of x, so I can just add them. So 1 plus half, right? So integral of dx is just x. Integral of 1 plus half is 3 over 2, and so 1 plus, so I get integral of x to the power 3 over 2 dx. Now by that rule it will be x to the power 3 over 2 plus 1 by 3 over 2 plus 1 plus c. 3x plus 3 over 2 plus 1 would be 3 plus 2 by 2, which is 5 over 2. 5 over 2 x to the power 5 over 2 by 5 over 2 plus c. So I get 3x plus 2 by 5 x to the power 5 over 2 plus c. Now let's take the next problem. So I strongly advise you to carry a pen and a paper while watching the videos, otherwise you will not understand anything. So YouTube provides you the opportunity to slow down the video, to pause it, whichever you want. So these are the advantages you get because we are using YouTube. The next problem is problem number 10. Integral 1 plus x square cube dx. For this we will use this formula, a plus b whole cubed. This is equal to a cubed plus 3 a square b plus 3 ab square plus b cubed. So you can always use this formula, a plus b whole cubed is equal to a cubed plus 3 a square b plus 3 ab square plus b cubed. So using this, you see that you can break down the first term as follows. You can write this as 1 cubed plus 3 1 square times x square plus 3 1 times x square whole square plus x square whole cubed dx. Now the first one, you can write this as 1 plus 3x square plus 3x to the power 4 plus x to the power 6 dx. Now it's very easy, you break it, you get integral 1 dx plus integral 3x square dx plus integral 3x to the power 4 dx plus integral x to the power 6 dx. You can take integral of dx is x and take constants out, x square dx 3x to the power 4 dx plus integral x to the power 6 dx. So this is equal to x plus 3 x 2 plus 1 by 2 plus 1 plus 3 x 4 plus 1 by 4 plus 1 plus x6 plus 1 by 6 plus 1 plus a constant c. So you get, simplify, x plus 3 by 3x cubed plus 3 by 5 x to the power 5 plus 1 over 7 x to the power 7 plus c. So you get x plus x cubed plus 3 over 5 x to the power 5 plus 1 over 7 x to the power 7 plus c. So it's very easy. So you have 1 plus x square whole cubed. You first of all need to apply just this formula, a plus b whole cubed. This is a cubed plus 3a square b plus 3ab square plus b cubed. So using this you can break it down as 1 cubed plus 3 1 square times x square plus 3 1 times x square whole square plus x square whole cube, just using this formula. Then you just simplify it, you get 1 plus 3x square plus 6 to the power 4 plus x to the power 6 dx. You break it, integral 1 dx, integral 3x square dx plus integral 3x to the power 4 dx plus integral x to the power 6 dx. Then you can take the constants out, so you can take 3 out, and finally apply to find out integral x square dx, x to the power 4 dx and x to the power 6 dx. That age-old formula, xn dx is xn plus 1 by n plus 1. So it will be x4 plus 1 by 4 plus 1, 2 plus 1 by 2 plus 1, 6 plus 1 by 6 plus 1. And then simplify. Now let's take the next formula, next problem, which is problem number 11. So integral x minus 1 divided by cube root of x square dx. Observe that you can write, so it is cube root of x square. So that means what? It is x square power 1/3. Now you all know that if you have 2 inside the bracket and 1/3 outside the bracket, the indices gets multiplied. So it should be x minus 1 divided by x 2/3 dx. This step is very important. So I have cube root of x square. So cube root of x square. So I can write this as x square power 1/3. Then I have x square and 1/3 outside. So 2 and 3, 1/3 will get multiplied. You get 2 over 3. Then after that you split. I have more than one term in the numerator and one term in the denominator. So I can write this as x by x to the power 2/3 dx minus integral dx by x to the power 2/3. So here I have to subtract the powers. So it will be x power 1 minus 2/3 dx. In the second case, I have 1 by x to the power 2/3. So this can be just written as x to the power minus 2/3 dx. So you have x to the power 1 minus 2/3. So this is just 1/3 dx, and you have x to the power minus 2/3 dx. Then just apply the formula. It will be x to the power 1/3 plus 1 by 1/3 plus 1 minus x to the power minus 2/3 plus 1 by minus 2/3 plus 1. So x to the power 1/3 plus 1 gives you 4/3 by 4/3 minus x 1/3 by 1/3. Then you can simplify this plus a constant c. Practice these problems again and again in your home, writing it down. First of all, try to understand how I did it, then take a sheet of paper, write down the problems and try to do it yourself without looking at the solutions, and practice each problem multiple times. So let's take the next problem, question number 12. So question number 12 is integral square root of x times 1 plus x dx. So first of all, you can write this as, you can just multiply them. You can write this as square root of x plus square root of x times x dx. This is square root of x plus, you need to add the powers, so it's half plus 1 dx. So square root of x is x to the power half, and 1 plus half is 3 over 2 dx. So then you break it, you get integral x power half dx plus integral x power 3 over 2 dx. You get x half plus 1 by half plus 1 plus x 3 over 2 plus 1 by 3 over 2 plus 1 plus c. So you get x 3 over 2 by 3 over 2 x 5 over 2 by 5 over 2 plus c. To simplify this, you get 2 over 3 x 3 over 2 plus 2 over 5 x 5 over 2 plus c. So it's extremely easy. So first you need to note that square root of x times 1 plus x dx. So you first break it, it will be square root of x times 1, again square root of x. Square root of x times x gives you square root of x times x. Then now square root of x is x to the power half, right? And square root of x times x. So square root of x means x to the power half, and at times x. So the power is 1. So the powers get added, half plus 1. I get x to the power 3 over 2. Then you split it, integral x to the power half dx plus x to the power 3 over 2 dx. After that, the formula applies. Now let's take the next problem, question number 13. Integral 1 plus cos square x divided by cos square x dx. Right, so you will split it. You can write this as 1 by cos square x dx plus cos square x by cos square x dx. So 1 by cos square x, from trigonometry you know that this is sec square x dx, and cos square x by cos square x is 1. Now if you look at that chart, you will see that the value of integral of sec square x, there is a formula. If you look at the chart of integral, it is integral sec square x dx. This is 10x. It's standard, so it's there in the table which I wrote down the formula. So integral sec square x dx, this will be just 10x, and integral of dx, this is just x plus constant plus a c, which has to be always added at the end. So remember, integral of sec square x is 10x. This is a standard formula. The next problem is very tricky. It's a beautiful problem. I love this problem. So let's try to do it. The problem is this: integral sine theta plus sine theta tan square theta divided by sec square theta d theta. So this looks very confusing to you, this integral. But if you look at this very integral very closely, you see that you have sine theta in the first term and also sine theta in the second term. So you can basically take factor sine theta out from the first two terms. As you factor sine theta out, what do you get? Sine theta, you get 1 plus tan square theta divided by sec square theta d theta. This is what you get, right? Now you see that from trigonometry you know that 1 plus tan square theta is sec square theta. So you can write down in place of 1 plus tan square theta sec square theta. So sec square theta, and also in the denominator sec square theta. So sec square theta cancels out. You are just left with integral sine theta d theta, which from the chart is minus cosine theta plus c. So 1 plus, so this is a very beautiful problem. Just let me repeat once again. So here I am given integral sine theta plus sine theta tan square theta by sec square theta d theta. So I can factor sine theta out. I get 1 plus tan square theta divided by sec square theta d theta. Now 1 plus tan square theta, from it's a well-known formula from trigonometry. This is sec square theta. So it will be sec square theta. I have sec square theta in the denominator. They cancels out. I am just left with sine theta d theta, which is minus cosine theta. This is also from the table, which I discussed a few minutes ago. Okay, so now let's do the next problem. This is problem 15, which is integral sine of 2x by sine of x dx. So for utilizing this, we'll use another formula from trigonometry, which is sine of twice x is 2 times sine x cosine y. This is often called the double angle formula. Double angle formula. This is a famous double angle formula from trigonometry. Those who have taken trigonometry very recently, I think all of you know them. Sine of twice x, or those who have taken trigonometry, these are taught in high school. So sine of twice x is 2 sine x cosine x. So using that, you can write down sine twice x as 2 sine x cosine x. It is called double angle formula because you see sine of twice of x can be expressed in this manner. So double of angle divided by sine x dx. Now you see that sine x cancels out. You are left with 2 cosine x dx. 2 can be taken out. You are left with just cosine x dx. Now from the chart which I gave you, you will see that the value of integral of cosine x dx is sine x. So I think all of you should basically, let me write down the 3 formulas we have used so far. One is integral of sine x dx. This is minus cosine x. Integral of cosine x dx, it is sine x. So this is the one we have used here. Plus c. So, and also I think in the last problem we had used this integral integral sec square x dx is 10x. So integral sine x dx is minus cosine x dx is sine x, and integral of sec square x dx is 10x. These 3 formulas we have used so far. So integral of cosine x is sine x. Now the last formula of this particular chapter on finding indefinite integral that we will do, and then probably I'll end my first video here. So, and then in my second video we'll be doing evaluation of definite integral. So in this video, so basically we did the 16 problems which were on indefinite integral. So in the next video which is coming up, we will be doing evaluation of definite integrals, and then combining these 2 videos you will be able to do your homework number 8. So homework number 8 will be basically based upon evaluation of this one, the indefinite integral, the definite integral, and also the average value of a function. So these 3 topics will be there in the homework 8. So the last problem for this lecture video. Problem number 16, which is integral of sine x divided by 1 minus sine square x dx. Right? So here again, to do this formula, we have to use, all of you know that sine square of x plus cosine square of x, this is 1. So from here, from this formula, if we subtract sine square x from both sides, you get cosine square x is 1 minus sine square x. If you subtract sine square x from both sides, I get cosine square x 1 minus sine square. So in place of 1 minus sine square x, I can write down this as cosine square x. Now I can write this as sine x divided by cosine x times cosine x dx. Now I am going to split it. In the first part I am going to write sine x by cosine x, in the second part 1 by cosine x. Now sine x by cosine x is 10x, and 1 over cosine x is sec x, and integral 10x sec x dx, this is known. This is another formula from the chart. Integral 10x sec x dx, this is just sec x plus c. So this will be just sec x plus c. So remember, it is very important to remember the basic formulas. One is integral xn dx equal to xn plus 1 by n plus 1, integral, the value of the integral of sin x, cosine x, and this formula. So these are all in the table in the note, and also if you rewind to the few minutes earlier, I already wrote down here. So these formulas you need to use. For example, here, and also some basic knowledge of trigonometry. For example, this is known that sine square x plus cosine square x is 1. From here, if I subtract sine square x from both sides, I get cosine square x equal to 1 minus sine square x. So in place of 1 minus sine square x, I can write down cosine square x. Now I can split it as I can write cosine square x as cosine x times cosine x. Now I can write this as sin x by cosine x times 1 by cosine x. Now sin x by cosine x is 10x and 1 by cosine x is sec x. So an integral 10x x dx is sec x plus c. So these are all the formulas. So I'm just writing what are the formulas we have used. One is this, integral xn dx xn plus 1 by n plus 1. The one which was used the most, we have used integral sin x dx, which is minus cosine x. This was used. We have used integral cosine x dx is sin x. We have used integral sec square x dx is 10x in the last problem, and also we have used in this problem this. So these are the basic formulas which are there in the notes also, which you need to do in all the problems. So this brings us to the end of first lecture. So you practice these 16 problems. You try to practice as many times as you can. Since this integration is new to you and these you will be used in the subsequent parts also, you need to practice all these problems again and again. If you have any doubts understanding any of these 16 problems on any part of this lecture, you can comment directly in the YouTube video below, and also you can email me directly, or you can I think that's the best. You can just email me, or just you can comment in the YouTube video directly. I'll be responding very promptly. Thank you all.